Good morning. Myself Prabha Ranjay, working as the assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic is analog filter from Unit 2 IAR filter design in digital signal processing. Okay. First of all, we should know about the filter. Filter is used to reject the unwanted frequency of the input signal and allows desired frequency. The frequency allowed by filter is called passband frequency. The frequency blocked by filter are called stopband frequency. Okay. Types of filter. There are two types, which is analog filter and another one is digital filter. Digital filter have two types. There is one is recursive filter, another one is non-recursive filter. Recursive filter is defined as the present output sample depends on the present input sample and previous input sample and previous output sample. For example of recursive filter is IIR filter, which means infinite impulse response filter, and non-recursive filter, which is defined by present output sample depends on the present input sample and previous input sample. Example of non-recursive filter is FIR filter, finite impulse response filter. Here we have to discuss the IIR filter, that is infinite impulse response filter. Okay, IIR filter, IIR system, length of unit sample response or infinite response h of n is infinite. Okay, infinite impulse response filter, the filter designed by considering all infinite samples of impulse response. In design IIR filter, the specification of an IIR filter is transformed to specification of an analog filter and an analog filter with transfer function. H of S is designed to satisfy the specification, then the analog filter is transformed to digital filter with transfer function H of Z. Okay. Advantages of digital filters. The values of resistor, capacitor, inductor used in analog filter changes with temperature. Since digital filters don't have these components, they have high thermal stability. The digital filters are programmable, hence the filter coefficient can be changed at any time to implement adaptive filters. A signal filter can be used to process multiple signals by using the techniques of multiplexing. In digital filter, the precision of the filter depends on the length of the resistor used to store the filter coefficient. And some of the disadvantages of digital filter. The bandwidth of discrete signal is limited by sampling frequency. The bandwidth of real discrete signal is half the sampling frequency. The performance of the digital filter depends on the hardware used to implement the filter. Some of the features, the physically realizable IIR filters don't have linear phase. The IIR filter specification include the desired characteristics for the magnitude response only. And comparison of digital and analog filter. Analog filter. The digital filter, it operates on digital samples of the signal, whereas analog filter operates on the analog sample. It is governed by digital filter governed by linear difference equation, whereas analog filter governed by linear differential equation. And digital filter consists of adder, multiplier and delay implemented in digital logic, whereas analog filter consists of electrical components like a resistor, capacitor and inductor. Whereas digital filter, the filter coefficient are designed to satisfy the desired frequency response. Analog filter, the approximation of problem is solved to satisfy the desired frequency. Okay. Analog filter, the frequency selective devices. Already we discussed, filter is used to reject the unwanted frequency of the input signal and allows desired frequencies. Okay, and based on frequency response, the filter classified into four types, that is low pass filter, high pass filter, band pass filter and band stop filter. Okay. Okay. The approximation problem is solved to meet a specific tolerance in the passband and stopband. In the passband, the magnitude approximated to unity within error of del of p. Stopband magnitude approximation to 0 within error of del s. Del p, del s are the limits of the tolerance in the passband and stopband. Del P, del S are also called ripples. The allowable frequency is called the passband frequency. The reject, which is the frequency blocked by the filter, are called stopband frequency. Okay. Whereas omega p represented as passband edge frequency in radian per second, and omega suffix s represent the stopband edge frequency in radian per second, and a suffix p represent the attenuation, that is gain at passband edge frequency. As represent the gain at stopband edge frequency. And omega p represent the passband, which means digital. Omega p, omega s frequency in radian per second. APS, whereas attenuation, which means gain. Here you can see the normalized magnitude response. Okay. This is ideal analog low pass filter, and left side is practical analog low pass filter, and cutoff frequency is 1. Passband is nothing but the allowable frequency, and stopband is the blocked frequency. And passband attenuation is AP. Stopband attenuation is, which is nothing but the gain, is AS. And tolerance is del P and del S, and 0.707 is cutoff frequency. This is the practical normalized magnitude response, low pass filter. And high pass filter, you can see high pass filter. This is the high pass filter, normalized high pass filter. And band pass filter. Band pass filter means this is the band pass filter. Within the band frequencies, only the filter allowable frequency, that is passband frequency. Other than that, other than the frequencies is stopband frequencies. This is the band stop filter. Opposite process of band pass filter is band stop filter. Okay. Next is impulse invariant transformation. The objective of impulse invariant transformation is to develop an IIR filter transfer function whose impulse response is the sampled version of the impulse response of the analog filter. The main idea is to preserve the frequency response characteristics of analog filter. It can be stated that the frequency response of digital filter will be identical with the frequency response of of the corresponding analog filter if the sampling time period t is selected sufficiently small to minimize the effect of aliasing. Aliasing occurs during the sampling processes, and here small h of t is impulse response of analog filter, and Laplace transform of the analog impulse response h of t gives the transfer function of analog filter. Transfer function of analog filter h of s equal to Laplace transform of h of t. That means 1 divided by s plus pk tends to 1 divided by 1 minus e power minus pkt z inverse, where capital T is nothing but the sampling time period, and a relation between analog and digital frequency is omega equal to, here you can see omega equal digital frequency omega equal to omega t, and analog frequency omega equal to omega divided by t. Digital frequency means omega equal to analog frequency multiple with time, sampling time period, whereas analog frequency means digital frequency divided by sampling time period. And S plan to Z plan, the poles map, whereas analog filter maps in S plan and digital plasma maps in Z plan, unit circle. And another one is bilinear transformation. Bilinear transformation is conformal mapping, transforms the imaginary axis of S plan into the unit circle in the Z plan only one, thus avoiding aliasing of frequency components during the sampling process. In this mapping, all points in the left half of S plan are mapped inside the unit circle in the Z plan, and all points in the right half of S plan are mapped outside the unit circle in the Z plan. It is 1-to-1 mapping. Capital T represents the sampling time period. For a formula for bilinear transformation is S equal to 2 divided by T 1 minus Z inverse divided by 1 plus Z inverse. Here left side, all points in the left side from the Z plan is mapped in this from the S plan is mapped in the Z plan is inside the unit circle, right side is outside the unit circle. Okay, if you have any doubt you can ask me through comment. We will meet in next video. Thank you.